I'd like to welcome everyone to attend the NGWA conference this winter, coming up fairly quickly here. We're approached by the National Groundwater Association, myself and a couple of my cohorts in the drilling fluid business, groutings, that sort of thing, to maybe come up with a presentation. And the presentation name took on a bit of an ownership of its own. In the exposition name is Overcoming Grouting Challenges, How the Professionals Do It. And I always hesitate to classify myself as a professional. It seems like I've just been doing it a long time, and you learn a lot of ways not to do something. I think Thomas Edison said we've learned 200 ways not to make a light bulb. So I think that's a lot in this industry of how we end up doing things. Not so much based on science, but the tried and true methods that we found that work in our particular situation. As my portion of this, I wanted to discuss cement grouting and some of the issues that we have and problems that we see on a day-to-day basis. And some of those problems are engineer-written specifications that don't make sense for what we're trying to do, all the way to implementation of getting the grout mixture that's designed in place. A lot of times mixes for grouting come from another industry, and they're never intended to pump 1,000 feet deep, 2,000, 5,000, 10,000 feet deep. So there's some real opportunities for failure right from the get-go. So what we're going to discuss is how do we manipulate, or what do we look for when we're reading a specification, when we are bidding the job in the first place. We go out and we're eager and we bid the job, we get the job, then we pull out the spec book and we say, oh, well, how are we going to do that? So reading the specification is a requirement, is the first step. And if you don't agree or don't have the equipment, or think you have a better way of doing it, by all means, go to the engineer, come to someone such as myself or some of my competitors. We see a lot of different applications. We're fortunate to travel across the country to a lot of different locations, and we see a lot of ways not to do things as well as ways that work pretty well. What I wanted to talk about was some of the problems with just basic cement grouts, and how do we overcome some of those problems. Probably one of the big issues is heat of hydration. A lot of thermoplastic pipe, PVCs, polyethylenes used in the drilling industry today that weren't used or aren't used in some of the other industries where these grouts and grout formulations came from. Also, densities of cement grouts. Lost circulation when you can't get the grout column to come back to the surface. What do we do? What's causing it? That sort of thing. So mitigation of some of these issues becomes what we do, or what we've become accustomed to doing, and helping the contractor, the engineer, look at these from a practical standpoint. From the engineering standpoint, they have a desire. They want the grout to perform a particular function. If it's a wholly structural environment, as a surface plate, versus the actual sealing characteristics of the grouting material itself, where we actually measure the permeability. So when we look at a typical grouting application for a water well, we see a lot of specifications for neat cement. From state to state, that varies anywhere from 5.2 all the way up to, in some cases, 7 pounds per gallon. Scratch that. Can you edit this? Okay. Neat cement grout. And from state to state, that can vary dramatically. Some states have 5.2 gallons of water per 94-pound bag of cement. 94 pounds being 1 cubic foot of cement. Other states go all the way up to 7 gallons of water. So it's a huge difference in the characteristics of the cement itself. However, when we travel from state to state, people think neat cement is neat cement. So you can see there's a wide range of properties that cement is going to have. Typically, if you add more water, you'll have more shrinkage. And for the purpose of this talk, we're going to talk about shrinkage as being lateral or horizontal, and subsidence being vertical, or losing it to the formation or the column shrinking down or settling down. One of the things that happen with with neat cement grout, if there's too little water in it, it doesn't have enough water to actuate the complete thermal chemical reaction. The Portland Cement Association identifies neat cement grout as 5.2 gallons of water in 94 pounds of Portland cement. And that's usually type 1 or type 2. With those numbers, that material will weigh just a little over 15 pounds per gallon. And at 15 pounds per gallon, it creates a very high head pressure. And can be easily break down the formation. If you think the drilling fluid in keeping it in the formation, when we start to throw away drilling fluid at just something over 9 pounds per gallon because its density is too high, now think about trying to keep 15 pound per gallon cement grout in the hole. So these can be real issues using a cement grout. Heat of hydration on thermoplastic pipe. I do have some slides that says how much heat is generated by a particular mass for neat cement. And the effects, also some slides that show the effects of the high temperature on that PVC casing. So if you've ever had a collapse from heat of hydration, you probably should show up and listen to this. There's a lot of valuable information. The other thing that we're going to talk about is calculating those densities and how we manipulate or engineer these cements to act in a way that make them either favorable to use around PVC casing or to give the engineer what he wants and actually maybe make a better grouting material for you, the contractor, to put in the hole. One of the things that we're going to talk about is how do you change the heat of hydration. You really don't change the amount of heat that's generated in that exothermic reaction that happens when cement comes in contact with water. But what you can do is spread that out either by time or by mass. So in other words, you're spreading the same amount of heat over a larger mass. It never reaches the high temperatures that it would in just a neat cement grout. The other thing is to increase the mass may also increase the density, so that may not necessarily be a good thing. Typically that's done by adding sand or some type of an aggregate. If you're using it for a grout, you got to have something that you can pump. But spreading it over time by the use of Additives such as bentonite will act as a retarder, and also some of the plasticizers act as retarders as well. They simply slow down that set time for cement. And you hear a lot of times about quick setting cement, but you hear very little about retarded cement, where the set time is retarded. And this really does allow for you to have a lot more flexibility in pumping time, also pumping ease. Keeps you away from flash setting and that sort of thing. So some of these additives, bentonite in particular, allows you to add more water to the mix. So there again, you're increasing the mass. For every action, there is a reaction. So with the addition of some of these products, other things are going to happen. They may be good, they may be bad. Primarily, whenever you add more water, you lose structural integrity of the cement. But we're going to discuss how important is structural integrity. When we start talking about a grout around a well casing, do you need 5,000 psi structural strength? Probably not. We've created some grout blends that have much lower structural strength, have very low permeabilities, and function very well. Good long pumping times, and never get above room temperature from a heat of hydration standpoint. So very friendly to PVC piping. So there's a lot of information, and we're each asked to put a small program together for about 15 minutes. So there will be some question and answer at the end of that 15 minutes, and then at the end of the 90-minute presentation, there will definitely be time for question and answers. But just speaking for myself, it's going to be fairly difficult to expound on much of the information I've already passed along to you in that 15 minutes. But please come to the presentation, and we'll see how good a job I do.